Hello and very good afternoon. My name is Ali. Today I will give a brief presentation about the Bernoulli equation experiment lab report 2. Let's start. First, introduction. According to the Bernoulli's principle, when area available for the fluid to flow decrease, then flow velocity of the fluid increase, and at the meanwhile, time the fluid pressure or the fluid potential energy decreases. This principle was named after Daniel Bernoulli, who first writes this principle in his book named Hydrodynamic. So there are some applications of the Bernoulli's principles such as airlift, air flight, baseball, draft, and others. So in our experiment, we have two main objectives. First, use the Wincher meter apparatus to study the effective area of the flow velocity and the fluid pressure. The second one is use the Bernoulli equation to compare the behavior of ideal and real fluid. So we have three main equipments: Wincher meter, supply hoses, and measuring tank. Let's talk about the procedure. First, we place the Wincher meter onto a horizontal surface and note the height of the input valve and output valve and make sure they're the same. Then we attach the apparatus with the power supply, but we keep the supply off. Then we open all the air bleed valves of the manometer present at the top. Later, on the power supply, we run the pump and adjust the flow rate control valve until the water level in all manometers is at readable range. This is the visual description of our experiment setup. Then we place the stop plug in basin and we note the time required to fill the basin with specific amount of water. Then we remove the stop plug to drain out all the water from the water place, and we place the dynamic pressure probe with the static pressure port and measure the manometer data from both probes. And later we place dynamic pressure probe with next static pressure probe and measure the manometer data from the probes. And we repeat the steps above for measuring data from all the manometer probes. And after we finished our experiment, we turn off the pump and set off our power supply. Now let's talk about the bit results. I won't go into details because we don't have too much time, but I will attach my presentation file for reference. So this is the sample calculation for height and velocity, and these are the results we got from the calculations for different probes. And these are the graphs for theoretical values and experimental values. Now, discussion. From the calculation, it's very clear that with increase in area of the flow, velocity increase and the pressure decreases. As shown in the graph of all three tests, that the decrease in area of flow decrease the height of water in manometer columns means they are directly proportional to each other. Difference in the theoretical and measured value, it can be said that water is not an ideal fluid, and height of water in the final column wasn't equal to the initial values, which show that there are friction losses in water particles. And this type of information is very useful in the case of nozzles, jets, and diffusers. And for the conclusion, aim objective of this experiment was to discuss the behavior of ideal and real fluid, and on the basis of test result, it can be concluded that the experiment was successful because there is small difference in measured and theoretical values. This is because of the friction losses in the real fluid. Ideal fluid doesn't have the friction losses. From the experiment, it can be concluded that with decrease in area of the flow, there is an increase in the velocity and decrease in the flow pressure of the fluid. And that's all for my presentation. Thank you so much for your watching and have a good day.